Okay, question 9 asks, what do you do in acid-base? Okay, so I'll give a general definition of acid-base titrations. So titrations are used to determine the concentration of A or B by neutralizing so by A or B I mean acid or base. So by neutralizing it with a standard solution of either acid or base, depending on what you're trying to look for. So if you're trying to determine the concentration of an acid, you would neutralize it with a standard solution of base. And if you're trying to determine the concentration of a base, you would neutralize it with a standard solution of an acid. So the standard solution has a known concentration. So during titration reactions, a pH indicator is used to monitor the progress of the titration. Okay, so let's see what the junior tutor said. Titration is a technique to determine the concentration of an unknown solution. In any titration experiments, there are several parts of the titration setup. You have the titrant, which is the solution of known concentration, which is added to another solution whose concentration has to be analyzed. So this is like our standard solution. And the analyte is the solution whose concentration has to be determined. These substances will react, and the reaction is an acid-base reaction which results in salts and water. During titration experiments, the use of indicators is essential because this will tell you the end point of the titration experiment. Indicators are substances that change in color in response to the chemical change caused by the change in the concentration of hydrogen and hydronium ions in the solution, since they change the pH. The common materials and equipment to be used in any titration experiments are the acid, the base, the indicator, burette, the clamp and stand, beakers, flask, and safety goggles. The general steps in performing titration laboratory experiments are... Okay, so here they have a nice diagram showing that you have your titrant that starts at your initial reading, and then you slowly let it react with our analyte of unknown solution. And then once the indicator turns the analyte pink in this example, this is when we would stop adding our titrant. And when we read the volume of titrant that was added, then we can calculate the concentration of our analyte. So they have here a step-by-step solution. Set up the equipment, fill the burette, take the reading before you add anything. Place the flask with the unknown concentration, add indicator. Slowly add the titrant while stirring the flask in a circular motion. Keep adding until visible color change happens, and then take the final reading and then calculate the pH. Yep, so this solution is correct.